We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
How do we accelerate the transformation to low-carbon buildings and homes? I'm Cait Hewitt, Policy and Engagement Officer at the Grantham Institute at Imperial College London. Joining me today are two fantastic guests, Dr. Jan Rosenow, Director of European Programmes at the Regulatory Assistance Project, who brings extensive experience in energy policy and decarbonising heating systems, and Max Waddingham, Operations Director at Good Energy. Max's hands-on experience with heat pump installations provides a unique perspective on what it takes to make this technology work for people and homes. Together, we'll explore what heat pumps are and how they work, the challenges and opportunities in rolling out this technology, and how we can bring the public with us and build the momentum needed to drive widespread adoption. Great. Really happy to be here today with two experts in the heat pump space. Jan Rosenow is Director of European Programmes at the Regulatory Assistance Project, or RAP, is that how you say it?
Yeah, RAP is quite right, yeah.
Good. And that's a clean energy non-profit organisation. And you're also a researcher with various universities, is that right, including
That's right, Oxford, Cambridge, Sussex and Free University of Berlin.
Great.
Just a couple.
And Max Waddingham is a design engineer, currently working as Operations Director at Good Energy. And that's a UK energy company. It's been providing its customers with 100% renewable energy for a long time, right?
Yeah, that's right. Yeah, energy, heat pumps, solar, EV chargers. Try and give a whole home approach. But very pleased to be here.
Great. So I'm Cait. I work here at the Grantham Institute at Imperial College London, and we operate as a kind of climate hub at the university. I work within the policy and translation team, and we help to ensure that policymakers have access to the best climate relevant research from across the kind of academic community here at Imperial. And I'm really grateful for the opportunity to speak to you both today, because heat pumps is a topic that we're keen to kind of get stuck into. So just by way of really brief introduction, why does this matter as a topic? We know that almost a quarter of UK emissions are from heating buildings. That's partly because a lot of our homes are really leaky and poorly insulated. But it's also because we're mainly using fossil fuel for our heating, whether that's gas boilers or plug-in electric heaters or even oil boilers in some cases. And we know there's a big hope within government and expert bodies like the Climate Change Committee that the answer to this problem is going to lie in heat pumps. So that's why we're talking about that today. So let's just start with a bit more, maybe by way of introduction. So I'd like to hear from both of you about what you do as it relates to heat pumps, how you came to be working on this topic, and maybe one thing about heat pumps that excites you. So who wants to start?
I'll have a crack. Yeah, I'll go for it. So Max Waddingham. So how did I get to where I am with heat pumps? For sure, starting there. So I, very unusual path, joined the army out of school, 16 years old. Spent 11 years in the army. But about halfway through decided, engineering is actually quite exciting. So army funded some study there. So I kind of reached the end of my engineering degree, left the army and went to work at a company called Valent, who are a manufacturer of boilers, commercial boilers, heat pumps, amongst other things. German company, but head office in Belper for the UK. And spent a lot of time there in a system technologies team, a bit of kind of R&D, design engineering, things like that, learning the ropes under a great guy called Martin Butcher. Taught me kind of everything he knew, which was vast amounts about the heating industry, and it was a lot. I think a lot less boring, more exciting than it would appear from the outside, actually. And there was some really great work going on, really good innovative technologies, heat pumps being one of them, being used in domestic properties. And so after a little while there, I think 5 years at Valent, I moved on to what at the time was Igloo Energy as I think senior design engineer, rolling out heat pumps for Igloo Energy. Was an energy company before they were acquired by Good Energy, and just through some opportunities moved into the operations space and now look after the survey, design, installation and customer care teams there as well. I think the other question you asked there, what excites me about heat pumps, or what do I like about heat pumps? Just how simple a solution it is. It appears very complex, and there's certain aspects of it are very complex, but essentially it's a boiler that sits in your garden, it plumbs into your house, and it will keep you warm, and if done right, it will reduce your running costs. So I just like how simple it is, and I just love getting the opportunity to tell people, to convince people how good a solution they are, because they do work. They are a fantastic means to reduce emissions for your house. My house, my wife and I and my kids, we have a heat pump, we have solar, we're on a Good Energy tariff, so we are a zero emissions house. We've got a hybrid car, not an EV on the drive, but charge that. So our emissions from the house, from the point of use, as we would call it, are zero, thanks to, in big part, having the heat pump.
Great.
I've worked on energy for about 20 years, and a lot of that was on energy efficiency in buildings. Then I sort of realized to actually go to zero carbon, it's not enough to just reduce demand with insulation. You actually have to tackle the source of the heat, which is, as you've pointed out, mainly gas in the UK and oil, some electric already. So I got really interested in heat pumps about 5 years ago. And in my current role at RAB, what we do is we typically look at what are the best policies, regulations that can drive the transition to clean energy. And that's not just in the heating space, that's also in transport, that's in industry, it's in power markets, gas markets. How can we actually transition from a fossil fuel economy to one that's based around low carbon sources? So for heat pumps, what we have done over the last few years is to look at the places that have already done this, right? The UK is not the leader in the world. There's other countries that have done this already. So when you look at countries like Norway, for example, or Finland, or Estonia, or Lithuania, those countries have basically transformed the heating market entirely, and almost all of the heating sales for individual buildings in those countries are heat pumps. So the question that we ask then is, well, how have they done that? What are the policies that underpin that transition in those countries? And distilling those into a heat pump policy toolkit, which we just launched a second edition in Baku at the climate conference, hoping to share best practices, experience from other places, to then leapfrog. So if other countries like the UK want to adopt the best policies, well, there's a whole lot of evidence we can draw upon. And one of the roles that I play is in sharing that information, also sharing research on heat pumps. I mean, I've done a lot of myth busting over the years because there's a lot of misinformation out there, and still a significant portion of the public believe in those myths. For example, that heat pumps can't heat old buildings, require dramatic amounts of insulation, won't function when it's below 0 degrees centigrade. So I've done a lot of work looking at the best available evidence, data, independent research, to bust some of those myths and essentially play the role of an advocate for heat pumps, but based on science, based on evidence. Why do I like heat pumps? To come to that question as well. Well, it is frankly the most efficient technology for heating ever invented. There's no other technology that comes even close in terms of the efficiency. And basically what heat pumps are doing, they're harvesting pre-existing heat from the ground, the air, the water, or maybe a waste heat source, compress it, transport it, and put it to good use. So it's much different technology compared to fossil fuel technologies that burn a fuel, much more efficient. And therefore, I think the CCC and others have identified it as the key technology for decarbonizing heat.
I'm really interested to hear a little bit more about this topic that I've heard, because I've heard you talk about this before. Is it right that there is enough energy existing already in the natural environment to actually heat all of our homes, and that we don't actually have to burn stuff in order to generate heat? That's a hard thing to believe sometimes on a cold wintry day in London. And also, I don't know, it feels like a sort of magic almost if you know, there is enough. Is that right? Am I right there, that there's enough energy out there?
Absolutely. I mean, theoretically, there's energy in the air all the way down to minus, I think it's 273 degrees centigrade, which is 0 Kelvin. And anything above that means there is energy somewhere. Of course, technically, you can't harvest energy at minus 100 degrees centigrade. We don't have the technology to do that. But there's plenty of heat available, energy available you can extract from the air, even at minus 15. And they are now called climate heat pumps. In the US, for example, there's been a competition run by the Department of Energy. And the latest models that they bring to market now can still operate pretty efficiently down to, I think it's minus 26 degrees centigrade. So it's perfectly possible to do that. You just need the right refrigerants, the right technology, and then you can even at very low temperatures get decent efficiency out of heat pumps and harvest that ambient heat.
Can we talk a bit about how that actually works? I don't know if Max, you want to come in here in terms of how does the heat pump extract this energy and bring it into our home?
Absolutely, yes. So, you know, as Jan says there, the energy's in the air. The thing that's different about a heat pump from, say, a gas boiler. Gas boiler, you burn something, generates heat. You know, cavemen have been doing it for millennium. But with a heat pump, you're moving heat. You're pumping heat from one place to another. You're not creating it in the appliance itself. So the way that works is, just keep it fairly simple. There's a refrigerant inside there. Let's imagine it's a moving kind of circle. This refrigerant, you know, pick one of them, R32, common one in heat pumps at the minute. It boils at something like minus 52 degrees Celsius. So unless it's going to be kind of minus 53 on a cold London day, that refrigerant can boil, and that's the key thing to producing this heat. It's absorbing heat. It's turning from a liquid into a gas. It's going through the system. It then hits this part called the compressor, condenses this refrigerant down. The way this has been explained to me, which I always like, is a bit like a bicycle pump, putting your thumb over the end and having a go at the bike pump. It gets warm on the end. That's generated through the compression of the gas and produces a great amount of heat. This is where your electrical consumption comes in. It's moving the compressor and the pump that moves the water around on the other side. And basically, it's just got a heat exchanger, like a radiator inside, and it just moves from there into your heating outlet, be it a radiator, underfloor heating, hot water cylinder. So it's not creating the heat in the heat pump, it's moving it, it's using the ambient air to provide energy to this refrigerant cycle. Been around for years. If you've got a fridge, it's the same thing. The warm fins on the back of your fridge, this is your kind of, your butter and sausage roll powered heat pump. It's warming the back of your fridge from the energy that's in the contents of your fridge. It's the exact same technology. So,
and in terms of efficiency, I think you both mentioned that these are kind of an unusually efficient piece of technology. Is that right?
Yeah, I mean, just to put some numbers to this, perhaps. I mean, typically an efficiency of 300% would be observable for heat pumps in the UK. Then people would say, well, 300% is impossible because you're breaking thermodynamic laws, and it's a shorthand. Of course, you can't burn a fuel and get more than 100% efficiency out of it, but because the heat pump is actually just moving pre-existing heat, what the efficiency here means is the coefficient of performance, or the seasonal coefficient of performance over the course of a year, means how many units of heat do I get for 1 unit of electricity. So with a heat pump, you might put in 1 unit of electricity, you're getting back 3 units of heat, maybe even 4 or 5. So there's now competition actually in the UK for the most efficient heat pump. Heatpumpmonitor.org, you can actually see a ranking of the most efficient heat pumps, and there's a few Valent heat pumps, I think, in there, the Aerotherm, but also some other brands and models. And what we find there is that in some cases, there's a seasonal coefficient of performance of 5, which is extraordinary for an air source heat pump. That's extraordinarily high. So you can get 5 units of heat for 1 unit of electricity if the system is designed extremely well. And that makes heat pumps so attractive because of that ability to use 1 unit, but you get up to 5 units out of it. So that's how they work.
Right. I think you've both made a really good case for heat pumps. So we have to talk about why it is the case that we haven't all got these things. What are the kind of key barriers to take up at the moment, and what can we do to overcome those? So maybe Max, if you want to start us off here, there are practical issues, aren't there, that people need to address. You can't simply bring in a heat pump and install it where your old gas boiler was. So could you talk us through a little bit, what is the kind of minimum changes you need, I suppose, and what are the complications that might come with different kinds of buildings in terms of heat pump installation?
Yeah, of course. So a lot of the efficiency we talk about with heat pumps, it comes from how low can you run your heating in terms of not your thermostat in your house being 21 degrees, but how low can we keep the temperature of your radiators to put that energy in. So a bit of a challenge with that is your gas boilers, your oil boilers are put in sometimes 80 degrees through these radiators, a lot of heat in short bursts. And what we try to do with heat pumps is low and slow, to use the barbecue term, but keep it on all the time, running at a low temperature in your radiators. And what you need to do in a lot of cases for that to happen is increase the surface area of the heat-giving parts of your building. So, bigger radiators is the most simple way to put that, or big areas of underfloor heating. So unless your house is kind of already set for that, you might then have to upsize a lot of these radiators or underfloor heating. Now, what we've been quite, I guess, lucky with, if we want to say that way, with retrofit for certainly for domestic heat pumps is we size all the radiators. We calculate the heat of the building. So, we know a radiator X by Y size is going to heat this room. Historically, it was kind of sized by, well, the window's that big, the radiator will fit under there. So a lot of these are actually massively oversized for the type of heat that we've traditionally been using, oil, gas, LPG, that sort of thing. So I use my house as an example. It's a kind of early 80s detached house in Nottingham. We put a heat pump in. We had to change one radiator. I chose to change several just so I could get it even lower, but we had to change one, and I had to put a new cylinder in just because the one I had was ancient. Again, that was my choice. I could have kept it. It would have cost me a bit more to run. The installation took place over 3 days in my property. Generally speaking, on average, we're seeing about 5 days. So, we might have to change pipe sizing because, again, in the UK, we've been very good at using really small pipe for efficiencies, cost saving more than anything, I guess. I say efficiencies of the wallet, not of the appliance. So sometimes we might have to upsize pipe. So it can be a very intrusive, very labour-intensive installation, which comes with cost, therefore is quite expensive. That's not to say it's every case, but it can be expensive. You can change a lot. But the key thing I always point out there as well is that's not the cost of the heat pump. You can't put that down to the cost of the heat pump because you'll do that kind of retrofit thing once. A lot of new build properties now, I say a lot, not all, they're regulated to be designed at 55 degrees and below, so this kind of low temperature, very efficient heat. But if you've got that in place, the next time you need to change your heating system in 20 plus years with a heat pump, it's going to cost you what it would to take a boiler out and put one back in. So it's not the heat pump that costs the money, it's the work that goes on around that. And
how long did you say, sorry, the heat pump itself will last typically?
If it's installed well, 20 years is kind of the given time by the manufacturers at the moment. So.
Okay. And I've heard that one of the problems is that if people just wait until the boiler breaks, it's a bit late at that point. Is that right? To kind of do the work and figure it all out in terms of how to actually replace that with a heat pump system.
Yeah, that's we would call that a distress purchase. You're buying it because you need it, not because you've planned. People buy new cars, they plan for a while and they know what they're going to get. If your heating breaks, especially in the middle of the winter, what's the quickest, easiest, cheapest way to get my house warm again? Generally speaking, you will replace what you have. So you have a combi boiler that comes out, a new one goes in. You don't question it, it's very quick. So heat pumps, generally speaking, for retrofit anyway, would be more of a planned purchase. Somebody knows they want to do something good for the environment. They have seen the government grant that's out there. They plan for that. If somebody's boiler breaks, it's very hard to get a heat pump designed and installed in a week or less. I think companies like Octopus, I think, have got an 8-week wait to go in. I know we're working at 2-month lead time for installations at the moment. So there just isn't the skill set and the depth of engineers in this country at the moment to be able to replace them with the speed that you could with another heating appliance.
Yeah, skills, I'm sure, is part of your policy toolkit, is that right? Building up skill sets.
Yeah, I mean, skills is one, but I think just to come back to your question about the barriers and why haven't we deployed them at a much larger scale in the UK? I mean, one of the key barriers is the so-called spark gap. It's the ratio between electricity and gas prices. So right now, we're talking about, roughly speaking, 4 times higher prices per unit per kilowatt hour for electricity compared to gas. And even if you have a very efficient heat pump that, let's say, gives you a coefficient of performance, seasonal coefficient of performance of maybe 3.5 or above, you're actually struggling to see substantial savings. You might be breaking down in terms of the running costs with a gas boiler, but is that enough to really get you to the point where you're willing to you put up with the higher upfront cost, with the hassle? Probably not for a lot of people. So it's really important to bring that down. And I have actually plotted on a graph the penetration of heat pumps, so how many heat pumps per household in a country versus that ratio between electricity and gas prices. And it's not a perfect correlation, but it's a very clear trend. So the UK is at the bottom of the list because we have the highest ratio in Europe between electricity and gas prices in the domestic sector. And then when you look at the other extreme, it's Norway, Finland, where the ratio is pretty much 1. So automatically, once you switch to a heat pump, you basically paying a fraction of the running cost, and therefore it's a no-brainer. That's why we see those heating markets being what they are, where nobody buys fossil fuel systems anymore because the economics just don't stack up, doesn't make any sense.
And why is that the case in the UK? It feels as though, if we're increasing the amount of renewable electricity that we're providing, and the government has this target, don't they, now for clean electricity by 2030, that automatically that should be bringing down the cost of electricity. So why is that not the case?
There's a few reasons for it. Let's start with the easier ones first, perhaps. So we have a carbon tax, effectively on a carbon price on electricity. There's an emissions trading system, used to be the European one, now it's the UK one. So there's a price per ton of carbon that you emit in the electricity system, but there is none for gas used in domestic boilers. That's number one. Then we have a lot of policy costs, such as the money that we all pay for with our bills for energy efficiency programs. This goes back all the way to the early 1990s that they have been introduced, but also the renewable programs that were funded in the past, feed-in tariffs, renewable obligations on the energy suppliers. Those costs are primarily funded through electricity bills. The main reason being that everybody pays for electricity, not everybody uses gas. That was partly the rationale why those policy costs were added to electricity bills. But what that means is that the decarbonization policies are being paid through electricity, yet we want people to switch to electricity using heat pumps and electric vehicles. Doesn't really make a lot of sense, right? Because we're actually disincentivizing them switching to those fuels by adding the costs of all the policies to electricity, but not to the other fuels. So that distorts the prices in a fairly significant way. Just to give you sort of a sense of, before the crisis, almost a quarter of all the electricity costs for domestic customers were for so-called green levies, which are those kinds of policy costs. And then the third reason is that electricity prices are still pretty high in the UK, and that's because gas typically sets the price in wholesale markets. I guess you could do a whole episode on sort of why that is and how these markets function. But most hours of the year, gas sets the price, and gas prices are still above pre-crisis level. And in fact, there's now signs that there might be a tight supply this winter because we had a fairly cold period now in November already. So we see continuous high gas prices. That also means we have high electricity prices. The way out of that is to reduce the number of hours in the year where gas sets the price. And that's exactly what the government is trying to do, with their 2030 goals of decarbonizing electricity. But that's hard. It's hard to do, and that's why we haven't seen prices come down yet. So once you address all those three elements, you actually would see electricity prices come down sufficiently. And then you create conditions where actually at some point you can even go without government subsidy because your running costs are just so much better, and people will see the economics stacking up for heat pumps much more than they currently do.
Yeah, okay. Yeah, because the government subsidy at the moment comes in terms of the installation cost, is that right? But what we're saying is that also needs to be some kind of significant policy action around the kind of running costs. to make these economically
absolutely, because
viable,
it seems unfeasible to spend £7,500 for every single household in the UK as a grant to upgrade to a heat pump. When you do the numbers, that is a vast sum of money. But it's also not necessary. If you change the structural economics and make heat pumps the preferred choice, you can pay for some of the higher cost with your cost savings. And in the meantime, the cost of heat pump installs is starting to come down as you scale. At least that's the expectation. And in other markets they have. So there's evidence on the degree to which heat pump costs can come down, and that happens once you scale the market. So again, you have another opportunity to then lower the amount of subsidy required to the point where actually you may only focus on the low-income households, people who really can't afford it. But that's going to take a few years.
Okay. Yeah, and just really briefly on this topic, you're quite right that it's a huge topic, isn't it, that could have easily its own show. But if this is quite a difficult, intractable problem, this kind of spark gap issue, what are the kind of shorter term workarounds? Do you think if we address those first two topics that you talked about, if the government was to do something about the policy costs, for example, is that enough to help to get this market going, do you think, in the short term?
It would make a significant difference. And we actually have a paper coming out, I think, hopefully before Christmas. It's just been accepted by iScience, looking at the total cost of ownership of heat pumps. So it's not just looking at the running costs, but at the whole package after the grant that the government offers. How do the economics stack up? And what we've done is sort of modeled a scenario where let's shift the policy costs away from electricity into the public budget, which is one of the options that policymakers have at their disposal. How would that change things? Would already make a big improvement. The second scenario model is if you put it onto gas bills, what would that look like? Much bigger effect, because not only are you lowering electricity prices, but you're also increasing gas prices. Politically difficult to do for the obvious reasons, right? And then there are sort of hybrid solutions. You might also have an exemption for heat pump users to not pay for a certain amount of electricity, pay those policy costs. That's what's actually effectively happening in Denmark, where the first 4,000 kilowatt hours for heat pump users are almost tax-free. There's a very, very small tax on them, almost zero, in order to incentivize the electrification of heat. So there are different ways of doing it. You could also add a carbon price to gas. Again, that's politically more difficult. And government is looking at this, has been looking at it for a while. They just haven't published a significant proposal yet, how they're actually going to address that.
Okay. And just before we move on, to be clear, even today, it is possible to save on your electricity costs once you've got the heat pump installed, just because of the fact that they're so much more efficient. Is that right? Yeah,
absolutely. As Jan said, some heat pumps are getting 500% efficiency. If you take the look at my heat pump at home is about 400% over the year. As long as it's bigger than that spark gap that Jan speaks about, if it's 4 times as efficient as the boiler and the spark gap's 3 times higher, then you will save money running it. So,
okay. All right, I want to talk a little bit about public attitudes. You've both, in different ways, I'm sure, in the course of your work, talked to a lot of people about the heat pump issue. Lots of people seem to have views about them. This is what I found. If I just mention to people that I'm starting to work on heat pumps, I'm surprised by how many people have a story to tell. We were chatting just before. So let's talk a bit about that. To what extent do you think there are either challenges or opportunities in terms of how the public at the moment think about heat pumps? And I'm thinking of, for example, things like kind of general consumer concerns. Will a heat pump work? Is it going to be noisy? Can they trust it? Is it a new technology that they should be a bit suspicious of? I've also heard it argued that perhaps heat pumps don't have quite the same kind of bragging value as some other home investments. That what you really need is something that people will want to show off to their neighbours, and that perhaps we haven't quite got there on heat pumps. Or maybe more positively, that perhaps people need to be encouraged to think about heat pumps as a way of sort of future-proofing the home somehow, and maybe we haven't quite got there in the public thinking. And then really briefly, as a kind of final thought, I've heard it argued that we should be marketing heat pumps as a kind of patriotic choice because they mean that we don't really need to rely on, imported energy, I suppose. And at one level, that feels, a bit uncomfortable, a bit nasty potentially if we're talking about, we don't want the kind of dirty foreign energy. But if the reality is that, as we've seen, that we've historically been quite dependent on Russian gas, for example, means that if we don't want to accept that gas anymore, it suddenly can have a really quite significant impact on bills and things, then maybe there's some mileage in that kind of an argument. So I've just thrown out lots of things there. I'm interested to know where you think there could be most traction in terms of talking to the public about this.
It's a lot of good points there. I think that the public perception, there's been a lot of hard work from a lot of lobbying bodies to discredit heat pumps, I would say, in the past. A lot of press given to the one bad installation and ignored the 10 great ones. They do absolutely work. I will put my neck on the chopping block and say that if it's installed properly, it will work in any place you can heat with another appliance. Absolutely they do. I think you hear a lot about things like noise. Again, I was just telling you before that we had a customer very concerned with noise. They were replacing a boiler that was inside their bedroom and they were worried about the noise of the heat pump, which was going to be outside and was quieter than the boiler that was in this. So, a lot of, I would say, good work by those that don't want heat pumps to be installed. But, the way that you can change these public perceptions, or, Jan mentioned he does a lot of myth busting and things like that, is just giving the accurate kind of lay of the land. And just through doing good work, good installations, having people warm and comfortable with their heating, anything we can do to address the policy is fantastic as well. But they do work. There is a widespread use of them in North America, in Europe, all sorts of places. They've been around for, I think, longer than gas boilers, actually. I think I love to show on our training at work a quote from the Spectator magazine, heat pumps being great for heating your property. It's from an article in 1928 in the Spectator. So they have been working for decades. They do work most commercial buildings, hospitals, places like that. You don't feel cold in those. They're heat pump heated. So, I think the public perception is just, there's not that many out there in people's properties. So you believe what you read, you believe what you hear. And there has been an effort to discredit heat pumps. But I think, just through good work, we can start to reverse that.
Great.
I mean, the media discourse in the UK around heat pumps is pretty terrible. I would say toxic, at least in some newspapers. And especially the Telegraph, just to name one of them, has been at the leading end of that, which is really unfortunate because there is very good information out there on heat pumps. We have evidence from the UK, from other countries. There's data. People have actually looked into all of this in great detail, but that's not how it's been covered in a lot of the media debate. Just to give you one example, there's one journalist who recently said that heat pumps will never work in Britain, will never take off, and he's the same guy who predicted in 2007 that the iPhone was only ever going to be a luxury gadget, would never take off, would never change anything. We have sort of people who've been very wrong in the past about other technologies now sort of jumping on heat pumps, and they actually have zero experience with the technology. They don't own a heat pump. They've never seen one. They haven't researched heat pumps, but they write very, very strongly worded articles in these newspapers, and people read them. And we know actually from surveys that Good Energy commissioned that people believe those myths, at least parts of the population believe those myths, which is doing a lot of harm. How do we counter that? I mean, there's some great projects. So Nesta, for example, are running a project where you can visit a heat pump. So if you have a heat pump, you can sign up and say, I'm happy for people to come around my house and have a visit and see what that looks like, feels like. And then if you are interested, you can go on the website and basically put in your postcode and you can see where there's a heat pump nearby, you can see and visit. So these are the kinds of projects that I think will make it much more real, and people can look at one, talk to people who own one, and that will change perception. But of course, it might not be the people who are the most skeptic who will sign up for that. But I think with any transition, when you look at you sort of have these market transformation curves, right? You have the early adopters, people who are really committed, and then you have people who are interested in new technology. They might come next, but they're not necessarily the super geeks who go onto heatpumpmonitor.org and upload their data and have a live API feed of their coefficient of performance. But I think we're now getting into that segment where more and more people who might not be sort of energy geeks are actually seeing, okay, heat pumps are a viable option, start adopting this technology. What we need to get to is a mass market, really sort of the mass chunk of the market. And there will always be late adopters, people who are skeptics, who don't want to switch. That's okay. We don't have to start with those people right away. What we need to do is address those people who are open to technological change, interested in playing their role, playing their part. And we know that from electric vehicles, right? The UK market for electric vehicles is now about 20% new sales is electric. And that's up from only 1 or 2% just a few years back. So that market has transformed over a pretty short amount of time. We can do the same with heating. That would be amazing. And we're seeing actually the numbers for this year looking very, very positive. The heat pump market this year is up in the UK, and that compares very nicely to some of the continental European markets where heat pump markets have struggled this year, and the numbers have gone down. So the UK is doing pretty well this year, and the latest numbers from the boiler upgrade scheme applications are at record levels in October. So I'm pretty optimistic that we finally hit that point where we can actually move the market to a different scale.
And the boiler upgrade scheme, I think you've touched on this before, is this subsidy from the government kind of up to, is it 5,000?
7,500. That's been increased.
£7,500.
I think it was in October 2023. It's been increased to that, and the Labour government just confirmed continuation, and they've also increased the budget available for that scheme. So that's the primary mechanism. It's not the only one, but it's a primary mechanism in the UK that provides support with the upfront cost.
Great. Okay. The other thing I've heard it suggested is that we can use a little bit the fact that people now really like certain types of green technology. So solar panels are very popular, aren't they? That people kind of understand those. They quite like having those on their roof. They they feel like that's something to be proud of, and that if potentially you can offer people a heat pump installation as part of a kind of whole home upgrade program that includes these other measures as well, maybe that's a good way to go.
Yeah, definitely. It's green technology's been around for a while. It's different things have been attractive to different people. Jan mentioned there the EV market's gone up. That was a non-existent market 15 years ago. So the bragging rights you mentioned there, a nice shiny new EV on the drive is going to pull people in. Solar panels, you can show your friends from afar. Heat pumps not so glamorous, like you say, but it's definitely a market in there. I think what we're seeing. Jan mentions there the market shift. What we're seeing very recently is a lot of the big heating names are now offering heat pumps, whereas before it was kind of electronics companies, your Samsungs, Daikin's, Panasonics. These guys were the ones making heat pumps. You've seen that market shift now, and you've got I think I saw there's a Baxi, Worcester Bosch, Ideal heat pumps. Now these are historically boiler manufacturers now selling heat pumps. Between those three, that's 60% of the domestic boiler market. So these guys are now offering heat pumps. So that consumer confidence will maybe come with the brand names there. So so the route in being through renewable technology, as you mentioned there, with solar and things like that. But my opinion is the route in is getting the trusted brands on board, and then people, my Worcester boiler's broken, I want a Worcester heat pump now. That would be the way to do it.
I'm sure that's right. We talk about kind of trusted messages on this issue, don't we? And I think often they are your neighbours or your family, people like that. That seems like a really important kind of way of increasing confidence in these things. So things like people, if they haven't experienced a heat pump, hence presumably the kind of Nesta approach to try and make it feel more familiar. And give you a kind of human connection with people who have actually got these things. But also this issue around the boiler installer, they're an important messenger here, aren't they? If people have got a problem with their heating and they've got someone coming in who historically maybe has been a bit sceptical about heat pumps, that's potentially been a bit of a barrier, but also an opportunity, as you say, if some of these big brands are moving now. Yeah,
of course, that's very true. If you've had the same heating engineer for 20 years and they're coming in and telling you that you don't want one of those heat pumps, you want your new boiler off the back of the van, you're going to trust that person. They've been servicing your property for for a long time. So it's about getting the confidence of the installers, as you say. That's key to this transition for sure. And until I would say there's certainty in running costs and things like that, until there's certainty of market, they're going to go with what they know and where they can make the money, and where the big companies are pointing them, which at the minute is still gas boilers, I would say.
I mean, that's so important to get that certainty and clarity. I think the UK government is now committed to making a decision next year already about the future of the gas grid and the use of hydrogen, bringing that forward, because that's been hanging over the industry for such a long time, and there's been a lot of attempts. I think they haven't worked, it's pretty clear, but a lot of attempts to suggest that we can replace gas with gas, and we're not going to electrify. Heat pumps will play a role, but maybe in new builds, but they're not really going to play a role for properties, existing properties on the gas grid. We're going to replace the gas with hydrogen, and that's clearly not happening. The trials that the UK has started have all been cancelled. There's only one left in 5, but that's with a new purpose-built gas grid. It's not testing the existing grid, so that's not going to happen. It's highly unlikely the government will commit to that, but having that clarity, I think, will also help for industry to then make the right investments. Up until that happens, I think we're still in that land of, I'm not sure whether it's going to be heat pumps or maybe hydrogen. And I think it's important also for consumers to get that signal. It's like we're actually not going to maintain the gas grid forever. And indeed, what we're seeing in other countries around the world now is that entire cities are starting to announce end dates for the gas grid. The UK is still a long way from that, but this is the next step. Once you accept that this is not the technology of the future, then you have to look at what are you actually going to do with the gas grid and send that signal, and that will really make a dramatic difference in the perception of consumers whether or not they're going to install another gas boiler if they know in 5 years or 10 years time the gas grid will no longer work.
Yeah. Okay. So final question. I mentioned we kind of touched on a lot of this already, I think, but I mentioned at the start that our work at the Grantham Institute is about trying to kind of address any kind of policy gaps with relevant academic research. So I'm interested to hear from both of you, I suppose, if there are areas where you think, I know that Jan, obviously, as we've mentioned, you're active yourself in research, but areas where you think there are evidence gaps, maybe other things that we don't know either about heat pumps or their deployment, or kind of really key policy steps that could be taking place in the next year or two that would really help to start, getting some momentum around this kind of heat pump deployment that we know has to happen in order for us to achieve our carbon targets and climate goals.
Well, I think the argument Jan makes there on the economics of heat pumps is like the more we can get out there, like, look how much you could save doing this. If we take the right policy steps, research in that economic space, and at the end of the day, people will choose with their wallets. If we can make it more appealing prospect in terms of energy bills, it's much better for the consumer. It makes it easier to sell, and it is a zero emissions point of use heating appliance. So any research around the economics and getting that message out there for me is crucial.
We haven't really talked much about the electricity grid because, of course, that is infrastructure that potentially is an enabler but also a barrier for heat pumps. And when you look at the National Energy System Operator, NESO, scenarios for 2030 and what the zero carbon power electricity system could look like, flexibility, demand response goes up by a factor of about 4 to 5. And a lot of that flexibility comes from heat pumps. What we haven't done yet is to figure out how exactly that's actually going to work. There's some pilot projects, but I think more research into that area, how to use heat pumps as a resource to manage the grid, and a grid that's increasingly reliant on variable renewables, is super, super important and is an under-researched topic. There's now some evidence. Octopus, Center for Net Zero, have recently published some work around customers who are on a time-of-use tariff, the COSI tariff, and how they compare with customers on a standard tariff. And they have heat pumps, and they show a vast difference in behavior. But this is just the beginning. This is the first piece of research that is done this. It's only with Octopus customers, but I think there's a lot more that could be done around researching the benefits of heat pumps as providing flexibility to the electricity system.
I'm really glad you mentioned that, because that's also a key potential enabler, isn't it, in terms of us moving away from gas and having to fix the electricity price according to the cost of gas, because we've got to keep that going just in case things go wrong, that we need to find some ways that we can feel confident in kind of shutting that off altogether. And flexibilities are presumably part of that picture.
Yeah, absolutely. I mean, the more we can do on the demand side, the less we have to do on the supply side.
It's a really good point as well. I know at Good Energy, we recently came to the end of a 2-year flexibility study with the University of Southampton called Latent Project, and we were, for periods of up to 2 hours, ramping heat pumps down remotely up to 80%, really pushing it. See, where would customers notice? Yeah, people sign up to this trial. We're not doing it on the unwilling. But we had, I think, maybe one cancellation. I think that was me by accident testing the mechanism. But yeah, we've really kind of pushed what we can do with flexibility with the grid. We're just starting another trial on this over the next year or so with a company called Axel Energy. So seeing how we can flex the demand and the peak periods and the off-peak periods for heat pumps as well to make the most of that.
Great. I think that's probably enough for today. I feel like we've covered a lot of ground. Thank you both so much for your insights. If people want to find out more about your work, what's the best way for them to do that?
They can go to goodenergy.co.uk. They can find out about heat pumps, tariffs, anything like that from there. You can find me on LinkedIn. Search Maxwell Waddingham. I'll be on there. And feel free to drop a message.
Great. Yeah.
I have a website, janrosenow.com, but you can also go onto LinkedIn and search for my name. You find it pretty quickly. I'm very active on social media, so if you want to keep up with my work, best thing would be to follow me on LinkedIn or Blue Sky.
Brilliant. Thank you so much.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.